This video is on topic 2.1, types of chemical bonds. And today we're going to take a look at some different AP questions that deal with chemical bonds. My name is Alice Pudi, and I'm happy to be back with you on AP Daily. In the last unit, the last video, we reviewed different types of chemical bonds and talked about how you could identify them and some properties of those bonds, as well as taking a look at polarity related to those bonds. And so what I'd like you to do right now is to read this question and then answer it. So press stop, do those things, and then press play when you're ready to continue. For this question, answer A is the correct answer. If we take a look over here at the diagram, for phosphorus, we have an electronegativity of 2.5. Chlorine is 3.0. And so because phosphorus is less electronegative, it's going to have the slightly positive charge. Chloride's going to have the slightly negative charge, and the dipole arrow is going to point to the right since chlorine is more electronegative, which means that B is incorrect. C is incorrect. Chlorine and phosphorus are both nonmetals, so there's no C of electrons. And the bond type between phosphorus and chlorine is not going to be nonpolar, so the correct answer should be A. Now, please read this question and answer it. Press stop, do that, and then press play when you're ready to continue. To determine which bond is more polar, what we want is a larger electronegativity difference. So on the periodic table, silicon and chlorine are furthest away, which would indicate that they're going to have a larger difference in electronegativity. So that means that answer D should be correct. A student claims that fluorine molecule is more polar than hydrogen molecule because fluorine has a higher electronegativity than hydrogen. And do you agree with this claim? Explain or why not. For questions like this, remember there are two things that you need to do. You need to first state whether you agree or not, and then second, explain why. And you are given the electronegativity values here in the chart. So please press stop, answer the question, and then press play when you're ready to continue. In this case, you should disagree. Polarity, again, is not the same thing as electronegativity. So if I look at the electronegativities for the two atoms in H2, they both have the same electronegativity, which means their difference is going to be equal to 0. And in the case of fluorine, again, same atoms, which means their electronegativity difference is going to be 0. And since they have the same electronegativity difference, they're also going to have the same polarity. This is the end of the video. Thank you for watching. Please join me for the next video, which is on intermolecular forces and potential.